All right, my clock says 11:01, so we can kind of go ahead and get started. So first off, hello and welcome. Thank you guys for joining us today, for wherever you guys are from around the world. So good morning, good afternoon, whatever time zone it is. I appreciate your time dedicating an hour to learn with us here at Traffic Labs and discuss a little bit about Amazon ECS and the common API gateway challenges that are there. This webinar has kind of been put together with some interactions that from our current customers moving to Amazon ECS, and also some new customers that are looking to deploy traffic within the Amazon ECS, which they've already been deployed in, and they're trying to enhance their capabilities within the service. And so this is just to put some collateral together and give you guys a learning experience as well as some reference moving forward. But first and foremost, now if we can go to the next slide, I'll introduce myself. My name is Christian Termseed. I'm based here in the Eastern time zone, Georgia to be specific, here in the States. For those of you in the international space, that's the eastern side of the US. And I am the sales director for North and South America. So if you're joining from those regions, chances are you'll be running into me and coming across my desk along with our feature presenter today, Matt Elgin. And actually, I'm going to give Matt over the mic. If you want to just say a little bit about yourself, who you are and where you are located in the world.
Sure. Thanks, Christian. So my name is Matt Elgin. I'm a solutions architect with Traefik Labs, also based on the East Coast of the US. And I work with Christian and some of the other folks in our organization to help customers figure out how they can fit traffic solutions into their architecture, answer technical questions, all that sort of thing.
Awesome. Thank you, Matt. So if we can go to the next slide, I'll cover the itinerary today. And like I said, thank you for joining us today. We have an hour scheduled for this webinar, but wanted to briefly go over the itinerary as well as some ground rules. I'll be monitoring the Q&A and chat window there for some questions. But what we're going to do is we're going to have a dedicated Q&A at the end of the session. If we do have time, or if it makes sense, I'll interrupt Matt, especially when we get into the deep dive part of the webinar. I can ask him some questions that are relevant to the time. If not, we will have dedicated time at the Q&A. I promise you'll get your answer. But we'll start off with just a high-level understanding and introduction to ECS and Traefik EE. And this is just to give you some foundational knowledge to kind of build off of over the next hour, right? So whether you're joining us already in ECS or you're considering it for future projects or migrations, we'll just touch briefly on it just for some clarity. But then I'll be turning it over to the technical guru, Matt Elgin, and in order to discuss, a technical deeper dive into the common challenges, as well as running you through a demo, because we want you to visually see how this is going to interact with your environment. And that's really what it's all about. And so this is meant to be an interactive experience as well as an educational. But at the end as well, I'll share my contact information, or you can connect with us online with one of our forum fills. If you would like to have a follow-up conversation after the webinar, we're happy to oblige and get that accommodated. But with that being said, I want to make sure we get enough time for Matt at the end. So if we can go to the next slide, Matt, we'll go ahead and start with the introductions of both Amazon ECS and Traefik Enterprise. So one more slide forward, please. There we go. So for those of you who are new to Amazon ECS, there's some key things that you should know. Obviously, what ECS stands for is at the forefront of everybody's mind. It stands for Elastic Container Service. And as you can assume, a lot of our customers inherently deploy on things like Kubernetes. But ECS is a strong contender and has been for a while, and is starting to become more relevant in conversations for many reasons. One, for it being efficient, for the automation side of ECS, which also helps with more of a simplistic deployment strategy. So there's many reasons that ECS is being used or considered in deployments, and we're just here to kind of help ease that a little bit more from the Traefik side. But in ECS, everything starts with a Docker container, and a Docker container is just technology that allows us as engineers, or I shouldn't say us as engineers, allows engineers to take their application code, their runtime engine, and any other dependencies and package them up as a container image. So once you have those Docker images built and uploaded into a registry like EC2, the EC2 registry, the next step is really getting those Docker images running on instances in the cloud. And that's where EC2 or ECS, I should say, comes into the mix. And so at a high level, ECS is a service for automating a fleet of instances and delivering your containers across them. So for the purposes of the webinar, what we're going to focus on though is, since there are 3 avenues within the ECS umbrella, we're going to be focusing on EC2, which relies on EC2 instances and the scaling group that you need to create along with that, as well as the Fargate mode, which is the fully managed offering from Amazon. So just a high level understanding there for Amazon ECS. Obviously, if you're tuning in around Amazon ECS, you either know about it, understand it, or you're already in it. So with that being said, let's move to the Traefik side and just cover at a high level as well what Traefik does, because I assume since you're here at a Traefik webinar, you have some sort of inclination of what we do here, but I'll go over for those that are new. With over 2.5 billion downloads, we're one of the largest open source projects in the world. We're one of the top 5 most downloaded Docker images in the world, and more than 650 contributors within our community. And that's from our open source edition. So what that really means, and the comfortability that it kind of gives you with all those metrics, is that it's just Traefik's widely used around the world in many organizations, right? And so to add to that, Traefik is built to be simple. And Traefik is also built to be cloud agnostic as well as provider agnostic, which means whether you're using Kubernetes today or you're a current customer using Kubernetes today, and you're looking to transition to the Amazon ECS tomorrow, Traefik here is basically to give you the tools on any containerized project to easily auto discover your services and APIs, easily auto configure the load balancing reverse proxy part. And that's what Traefik solves in companies' pain points in the market today. So basically auto discovery and then connecting to new services without having to restart, which is actually the major pain point that Traefik was built on to solve within Nginx 4 or 5 years ago. And that's kind of how we were born. So just a side story of how we kind of came to fruition. Our CEO, Emil, was working for a large insurance company and tasked to redesign 2,000 microservices. And he was having to constantly rewrite the YAML to update the containers with Nginx, which was obviously cumbersome, not scalable. And so as a side project, he took it upon himself to kind of create this project, and it grew, obviously grew tremendously to make it a huge open source and community driven project. But now it's a huge success in the enterprise world, and a lot of customers are switching to Traefik to handle their needs. But so sorry for the side story there, but back to Traefik. One of the things that I always want to mention is, and a major plus with using Traefik, is that it's written in Go. So unlike any other reverse proxy that is on the market today, the Go code is what it's based on, and it's going to be super simple. And like I said, lots of things that are going well with that. This slide is really just to paint a picture for you to see kind of what Traefik Enterprise does in 3 major categories. It's just a unified platform for your ingress, service mesh, and API gateway. Obviously, with any enterprise agreement or contract, you're going to get some sort of support tier tied to that. It's just an added factor into your consideration of Traefik and why customers are switching over to that, the enterprise edition as well. But now that we've covered, at least at a high level understanding of Traefik and ECS, we can kind of transition to the challenges and how this all fits together. So like I stated before, we got this idea for this webinar from current customers that are already deployed on ECS, as well as some customers that are transitioning to ECS. And what we did is we put 3 major topics to discuss and cover today from those conversations. And we understand each deployment from every customer is going to be different, but these 3 topics seem to be where most of our conversations at least started within the ECS space, and that are most prevalent in what we're trying to cover today. Matt's going to go into detail with each of these and how these common challenges are handled and give you some solutions as well. But just briefly going over that, the number one answer that we came with was handling the service discovery part within ECS, as well as number two, protecting APIs from abuse and unauthorized access. And that piece is relevant in all aspects. Doesn't matter where you're deploying. It seems like in the digital world, that authorization side of things and authentication side of things becomes extremely important in what customers are doing today. And then also we'll be discussing the supporting of the non-containerized services. And that will be the last topic or challenge that we cover right before the demo. But with that being said, I want to make sure, Matt, you have enough time for the deeper dive and run through. I'll be monitoring the chat, like I said previously, and then we'll bring up the discussion at the end for the Q&A. So Matt, if you would, take it away.
Awesome. Thanks, Christian, for the introduction. So like he said, we're going to go ahead and do a deep dive into each one of these challenges that we've seen. So we're going to start with the first one, which is handling service discovery within ECS. So this is a challenge that is going to be present in pretty much any container orchestration platform that we work with, ECS or otherwise. The fundamental challenge here is that by nature of a container orchestration platform, you have containers that are being scheduled on multiple underlying worker nodes. And to be able to route requests correctly to those containers, you have to have something that's handling that service discovery and knows how to correctly route to that correct location. So for each one of these challenges, I want to quickly discuss the implications of the challenge or the day-to-day impacts for teams that are managing these types of tools, as well as explore a few potential solutions that we might look at for addressing that challenge. So for this one in particular, those implications that we look at, first of all, if we want to address this routing of requests by just hard coding our IP addresses, the location of our services, that can be a common first step for trying to address this type of networking. But that's something that is quickly shown to be inflexible and is not something that is going to scale as you continue to add services and APIs, and is not really following those cloud native best practices and can result in brittleness in our infrastructure and network layer. Another step past that might be now still manually managing these routing decisions, but having to layer on DNS records. So rather than just plain IP addresses, we're creating records for where these are running. This is still something that's going to be time intensive and not dynamic enough to really keep up with that cloud native type infrastructure that we're trying to set up here. So a few potential solutions that we can explore. First of all, kind of the one that we discussed in the implications section, we can look at manually routing to either those IPs or those DNS records, which comes with the limitations that we just discussed. We can do service discovery through some sort of AWS native solution. So a common one for ECS is using something like AWS Cloud Map, where we can map DNS records to the services that are running in ECS. And the last solution that we could look at is using some sort of API gateway that has native ECS support that will do that service discovery at the API gateway level instead. So let's move to challenge number 2, which is protecting those APIs. So once we've handled the fundamental challenge of service discovery and routing successfully to those different services, we're now going to need to layer on some sort of protection layer. So that's going to be things like authentication, authorization, maybe other protections like rate limiting and things like that to make sure that we don't have sensitive API endpoints that are exposed to the public unnecessarily, or making sure that our services are not abused through DDoS attacks, et cetera. So there's some implications of trying to manage this challenge. So one of them is the common approach that we see where companies will try and manage these security layers, the authentication, authorization, et cetera, per API or per service. And that can work, but it can result in a lot of duplicated engineering effort if you've got your developers working on these fundamental security practices per API, that can start to become wasteful in terms of effort very quickly. Another byproduct of that is if you have these security practices separately managed per API, you're going to get a lack of standardization, which can end up with certain security gaps if you have team A that is not necessarily following all the practices that team B or team C might be doing. Another implication is that it can result in an over-reliance on the built-in AWS security features. So obviously using things like security groups and IAM features are best practices in AWS and are very powerful tools. But for defense in depth, they're not things that we want to solely rely on for protection of our APIs. So making sure we have a layer that is dedicated to protecting our APIs on top of those built-in security features is paramount as well. So again, let's explore a few potential solutions that we could look at here. As we mentioned in the implications section, we can manage those security features individually per API or per service, which is going to come with those drawbacks we just discussed. Another approach we've seen is standardizing those security related pieces of functionality in a library that's shared across the different APIs. So that can work as well, but obviously introduces complexities in dependency management, coordinating across the different APIs. The third solution that we can take a look at is centralizing security at the API gateway level with an API gateway that supports all of those different security features that we need to handle. So let's now wrap up with the third main challenge that we've seen with customers using an API gateway in ECS. And that is one that is not entirely contained in ECS itself, but is still very relevant to running an API gateway, handling those types of services. And that's dealing with the reality of enterprises that are managing containerized and non-containerized workloads, which is the case for most of the enterprises that we work with today. So implications here is that we need to deal with additional complexity as we're dealing across those multiple infrastructure types. On top of that, that means that your team is going to have to keep their skills up to date for both those containerized workloads, for those non-containerized workloads. It can also result in potential redundancy if you follow a common pattern that we've seen where sometimes we will end up with an API gateway for your container workloads and another one for your more legacy virtual machine or bare metal server workloads. So that can result in some inefficiencies if we're having separate tools that are managing those different types of workloads. So again, let's explore a few potential solutions. So the first one is one we just discussed in implications. So you can have separate API gateway solutions that are tailored to each of the individual workload types. A second option could be to use an API gateway that allows statically specifying where requests should go. So either IP addresses or DNS entries. You're just pointing specifically at containers or non-containerized workloads. It doesn't really matter where it's running. Obviously not super scalable or automated. The last solution that we can use is, again, relying on an API gateway that has those capabilities built in. So something that is natively able to support multiple service discovery providers. So being able to natively route to those containers, those tasks in ECS, being able to route outside to EC2 instances, et cetera. We can do that from an API gateway that's able to handle all of that. So to wrap up our discussion of these challenges and jump over to the next section of our discussion, the takeaway is that using the correct API gateway for your particular architecture is going to address all of these challenges that we just ran through. Which brings us to discussing Traefik Enterprise in ECS. So we'll start with a quick overview of how Traefik Enterprise fits into an ECS-based architecture. So the high-level view is that the different components of Traefik Enterprise, which we'll look at in a slide in the architecture diagram. Each one of those are deployed as services in the ECS cluster itself. So what that means in terms of deployment is we're going to have a task definition for each of the components, the controller, the proxies, the plugin registry. All of these will get deployed as tasks and then services in our ECS cluster. From there, Traefik has a built-in ECS provider that will enable dynamic service discovery of our containers in that cluster. So we'll look at how that works during the demo. But the short answer is that we are able to define the routing rules that we're going to use via labels in the task definitions of our backend APIs or services themselves. So we'll look at a quick architecture diagram of what a typical deployment might look like in an AWS environment. So we can start on the left-hand side where we've got traffic coming in either on layer 7 or layer 4. Generally, we'll have some sort of DNS entry, maybe managed via Route 53, that is pointing to our elastic load balancer out front of our ECS cluster. Typically speaking, when we deploy Traefik Enterprise and ECS, this is going to be a network load balancer that is operating on layer 4 and is really just distributing the traffic across the copies of our ingress proxies that are running as an ECS task. So with those out of the way, we can now focus in on the resources that are actually running within our ECS cluster. So obviously we've got one or more services that are running in the back end. So these can be our APIs, our applications, running containers as ECS services. The Traefik Enterprise cluster within the ECS cluster is going to comprise those components that we just mentioned on the previous slide. So we've got one or more controllers that is responsible for cluster state and managing configuration. It's going to talk to the ECS cluster for the purposes of service discovery for these backend containers. Those controllers or that controller is then going to propagate our configuration to the ingress proxies that we have running. And we'll have at least a couple of those running for redundancy and high availability purposes. And those are going to actually handle those incoming requests from our load balancer and route them to the correct location within our cluster. The final component that we've got in our architecture diagram is the plugin registry. So Traefik allows for implementing custom middlewares as plugins in Traefik. So in Traefik Enterprise, we have a dedicated registry instance where we'll actually import those plugins and use them like regular middlewares if needed. So with a quick overview of the architecture out of the way, let's now take a look at some of the benefits of running Traefik Enterprise in ECS. So the first one is that because Traefik Enterprise runs in the ECS cluster itself, that means that our API gateway is running much more closely to the ECS services themselves that the API gateway is protecting than if it were running outside of the cluster as another service or on virtual machines, et cetera. Another benefit is that because these are ECS tasks and services, we can manage Traefik Enterprise as part of a standard CI/CD workflow, just like we do for the rest of our ECS tasks and services. So we can plug that into whatever our automation pipeline is and manage that in a GitOps type fashion as well. As an extension of that, the routing rules that we are using for our ECS services are defined as part of our API task definition. So development teams can extend the definition of their deployment just by adding additional labels that Traefik will recognize without having to rely on an ops team or wait for that deployment to happen separately. And the last benefit is related to that last challenge we mentioned earlier, is that Traefik Enterprise provides flexibility for those containerized and non-containerized workloads. So because Traefik can support multiple providers at once, we can route to containers within the ECS cluster, we can route outside to EC2 instances, as well as some other examples as well. So with that introduction out of the way, let's now do a quick demo of Traefik Enterprise and ECS. So a quick outline of what we're going to explore in this demo session. We are first going to walk through the deployment process for Traefik Enterprise into ECS. Once that's deployed, we will walk through the deployment of a sample API running as an ECS service. We'll walk through the basic routing, how we expose that service through Traefik Enterprise using those labels. And then we'll wrap up by layering on some of those security features. So protecting our API with TLS, with rate limiting, and with JWT authentication. So I'm going to jump over to our documentation to start, and we will discuss our installation process. So as I mentioned in the overview of Traefik Enterprise, each one of those components are going to be task and service definitions that we're going to deploy into ECS. So we will set up controllers, we will set up task definitions for our controllers, for our proxies, and for our plugin registry as well. So we'll deploy all of those as task definitions and then services in our cluster. So to highlight that, I'm going to jump over to our code editor here and walk through an example installation script that we might use. So I've actually already gone ahead and deployed all of these files for the sake of time for the demo, but we can walk through the individual commands that we would use here. So like we said earlier, we're going to start by registering a task definition for our controller, creating a related service off of that task definition. Once that's up and running, the way that the different components communicate with each other within a Traefik Enterprise cluster is using join tokens. So we're going to grab that join token using this execute command right here. Once that's done, we can do the exact same thing to deploy our proxies, and then do the exact same thing to deploy our plugin registry. So once we do that, the only thing that is left to do is connect our command line tool called TCTL to the cluster. So TCTL is our Traefik Enterprise specific tool that we use to communicate with the cluster, to apply configuration, to do backups and restores, etc. So we'll use another execute command to actually connect, and then we can use that cluster from the command line. So we've again applied our static and dynamic config ahead of time, but we can go ahead and take a look at what that looks like for this ECS instance. If I jump over to our static.yaml file, you'll see we have the configuration items that are going to apply to the entire cluster and all of our services. So that's going to be things like setting up our entry points. So here we have traffic listening on port 443 and port 80. Here we're enabling our ECS provider for service discovery. So we're setting exposed by default to false, so we don't automatically expose all the services in the cluster, and rather we're handling it via the Docker labels that we're going to add. We're specifying the region and the cluster name so that we can point the provider to the correct cluster, and we're enabling our dashboard as well. There are a couple other features that we'll dive into as we start layering on some of the items as we work through the demo. For our dynamic configuration, we are also going to dive into the middlewares in a little bit, but the first thing that we're going to take a look at is the dashboard router rule that we've set up. So here we're exposing our dashboard where we can get a view into the configuration, the ingress objects that we have deployed for this ECS cluster. So at this point, we can jump back over to our browser, and I will click on our dashboard link, and we see here we've got the home page of our Traefik Enterprise dashboard. If we click into the cluster view to start, we can see the different components that we've deployed are all up and ready as ECS services. So we've got a single controller, we've got 2 ingress proxies, and a single plugin registry as well. So what we can do now is dive into our ingress section and start to look at our example API that is running as an ECS service and start working with labels here as well. So we'll go back to our script and scroll down a little bit. So we've got our first task definition that we're going to take a look at. So we have deployed this ahead of time as well for the sake of time in our demo. But this is a standard task definition in ECS. We're using our usual Traefik EE demo application, which is a variation of the Who Am I application, if anyone has used that in their testing with Traefik before. And the important thing that I want to call out in this task definition is this Docker labels section. So this is where we are handling all of our dynamic config for those ECS services. So first we are enabling it. So we're actually telling Traefik to pay attention to this particular service. We're telling it what port that application is listening on for our service. We're having it listen on our web entry point. So we're just doing plain HTTP at this point. And we are giving it a host rule to respond on this app subdomain. So we can see all that reflected in our dashboard. If I click on that particular app router, we see in our router details pane, all of those pieces that we've configured with our Docker labels are reflected in our dashboard. So we can do a quick test here by doing a curl of that endpoint. And we see that we get the expected JSON response back, which is giving us some information about headers and the requests that we've sent. So that's great. We've got all that working. We've got a basic service that is exposed via Traefik EE and ECS. What we're going to do now is layer on TLS protection. So I'm going to go ahead and update our service to the TLS task definition. And that will take just a second. So we'll let that run in the background. And while that's happening, we can jump over to our TLS task definition variation. So again, we're going to cue in on this Docker labels section where everything is the same. We have it enabled. We're listening on that same port for the container itself. And we are using that same host rule for that host name. The two things that we've modified here, first of all, we are now listening on the web secure entry point rather than plain web. And we are using the default certificate resolver. So this certificate resolver is a neat feature of Traefik that allows us to automatically manage our certificate issuance and renewal. So this is referencing a certificate resolver that we have defined back in our static config file. So you can see here, I have a certificate resolver called default of type Acme, where I am specifying my email and my TLS challenge, the challenge type for the Acme challenge that I'm doing here. So what this is actually doing is leveraging our integration with Let's Encrypt. So by doing this, all we need to do is set up the certificate resolver once and then reference it across the services that we need TLS termination for. And that's going to automatically negotiate that challenge with Let's Encrypt. It's going to store that TLS certificate and will handle the renewal once that expiration comes up as well. So with just that setup and then a single additional label in our definition, we've handled TLS termination for our service. So we can jump back over here and we see that our router page has been updated. We've got the same thing over here, except for web secure. And we now see the TLS pane is populated with our certificate resolver, TLS set to true, and all of that. So once more, we'll do a quick curl to test that. And notice here, the only difference is that we are using the HTTPS version of the URL versus the plain one earlier. So we'll run that and we see we again get a successful response, which is great. So what we now want to do is add some additional security protections to our application. So again, while we're doing this, I'm going to go ahead and update our service in the background. So what we've just updated is adding some middlewares to our Docker labels for this application. So you can see these are all the exact same up here. We're using TLS still, the same host rule. The only difference is we now have this middlewares line where we're referencing rate limit and JWT auth middlewares. You'll notice both of these are using the @Traefik EE right here. And what that means is that these middlewares are defined in our Traefik EE provider. So we're referencing across providers here. So this is really handy if we want to set up centrally managed middlewares, say authentication schemes and rate limiting that we want to use across multiple services without having to resort to lots of different Docker labels in our ECS task definition. So we've done that here. So we've got the rate limit middleware set up where we have a average and burst request per second set up to prevent against any sort of abuse of that endpoint. We also have our JWT authentication set up where we are basically checking for a valid JWT in the authorization header, as well as forwarding certain claim information to our backend and checking for the contents of that particular claim. So in this case, we're making sure that this user is part of the admin group. So we've got all that set up. Our JWT source is referencing back to our static config, where we have a source in our auth sources section. And here we're just using a dummy signing secret to validate that token. So we can double check that our definition has updated, which it looks like it has. So in our middlewares pane, we now see we've got both rate limit and JWT auth returned right here, which is great. So it looks like everything is working correctly. So what we can do to test that out again is first just do a plain curl command to that endpoint. And we see that we are getting a 401 response back rather than the 200 that we would expect. So what we need to do is include that valid JWT as part of our request. So we're using this jwt.io website to generate a valid token that's going to meet our requirements. So we've got our secret down here, as well as that group claim information that we need to check as well. So I've copied that into this variable here, which means if I do one last curl command, we see that this has now been successful as well. So we validated that JWT as part of our authentication flow. So let's do a quick summary of what we just talked about now that we've wrapped up that quick demo. So we've established the fact that running APIs in any sort of container orchestration platform, ECS included, is going to introduce certain common challenges that we might see. One of the best ways to alleviate those common challenges is to pick the right API gateway for that particular application. And we looked at how Traefik Enterprise can run as that API gateway in ECS with that built-in service discovery for those applications that are running in your cluster, as well as those additional enterprise grade security features that are layered on as well.